sir. Thank you.
Okay, let's start, Sir Argel. Good afternoon, everyone. Good afternoon to all our distinguished colleagues, Mr. President and Sir Argel. This afternoon, we will have training on programming. What's this? On PLC. Before we start, we will start first with our Philippine national anthem. Next is our ICPEP hymn.
Be connected, be united, be one of ICPEP. Build a network, strive for teamwork. Together we'll make a step. ICPEP has a vision to build new frontiers in computing science, technology, and engineering towards excellence and greater good of the people. ICPEP, a global institution, we partner research and innovation. We design and build enterprise systems to boost automation on a global scale. Be connected, be united, be one of ICPEP. Build a network, strive for teamwork. Together we'll make a step. ICPEP for global community. Collabs and train for the industry. We support human and tech development to create and build the future of humanity. ICPEP upholds our profession to enhance and strengthen our relevance. One vision, one mission. ICPEP engineers, we stand mightily. We are the future. We are ICPEP.
Okay. Stop share again. Okay, good afternoon, everyone. Good afternoon to all from different parts of Philippines, from our Bulacan State University, also with other schools here right now, and our professionals. This is a wonderful afternoon. I would like to introduce to you our President Ryan is here also in our training file as. Um, Sir, any words before we start?
Okay. Yeah. Thank you, Engineer John. Right. Okay. So good afternoon. So welcome to our one of our series of the webinar for this month. So this webinar is one of the shall we say, promising area of computer engineering. So this is Engineer Argel will discuss about the overview of PLC programming, which is a precursor of what we call advanced manufacturing, and we'll tackle a bit of interface with robotics engineering. Okay, so this one is very useful to our faculties in the field of computer engineering and allied professional, and also the future computer engineers. So I hope you will learn something for this session, and then I hope you will continue to support our organization as we move on to what we call the fourth industrial revolution. So we are looking forward to provide you a more interactive sessions or webinars in the coming months. So again, thank you for coming and supporting us. Okay. Thank you, VP John.
Thank you. Thank you, Sir Ryan, for those words. Now, I'm going to give the floor to our trainer this afternoon. He is Sir Argel. He is one of our technical trainers here in ICPEP, and also one of our officers also at the same time. Sir Argel, I give the floor to you right now.
Hello, sir. Good afternoon, VP Ryan, VP Jan, and VP President Ryan. So, good afternoon to all. So, today we will discuss about the introduction of the PLC. So, can I share the screen now? Sir Jan, do you need to discuss this one first, or should we we go now to our program PLC? Sir Jan. Sir Jan.
Okay, good afternoon again. We are ICPEP Singapore chapter, headed by our distinguished president, Sir Ryan Evangelista. And this afternoon, right, our aim, right, because we started the ICPEP in October 2012, headed by Sir Ryan, and this is the first chapter, international chapter here in Singapore. And our vision aim global group of professionals, computer engineers, IT practitioners, and a global think tank of group of interrogative engineers and computing towards a smart nation building. As one, Sir Argel, next po. This is the first team that was built in ICPEP-SG. We were the first, as before, as we have a photo with previous Ambassador Morales. And sometimes we'll have our team meetings and also our team buildings that we had previously before the pandemic. Okay, now I will pass it to Sir Argel for the presentation of this topic for the programmable logic.
Hello,
Sir Argel.
this is the introduction of a basic programmable logic controller, or the PLC. So let's start. So our objective is to define the basic component of the PLC, to apply PLC-based control to a manufacturing system, to implement, to be identify instrumentation required to implement a PLC control system, to program a PLC, and to implement a PLC control program and hardware. So wait. Wait. Okay. So our outline. This is our outline for today discussion. So what is the PLC? For the PLC, history, function, sizes, PLC construction, the advantage and disadvantage of the PLC, the components, the input and output type, the PLC structure, program execution cycle, programmable language used in the PLC, the ladder diagram, and then the logic, PLC instruction, connection instruction, and specific command. Maybe in the sample program, we will use the software to demo the program given in this presentation. So we will use the Kian software and HMI as the switches, switches since we don't have an internal or actual switches. So let's start. So what is the PLC? So based on National Electric Manufacturer Association US NEMA, so a PLC is a digital operating electronics apparatus which use a programmable memory for internal storage of instruction of implementing specific functions such as logic, sequencing, timing, counting, and arithmetic to control through analog or digital input-output modules various type of machine or process. So the purpose of programmable logic controller is to initially designed to replace a relay logic board sequencing device actuators, coordinate activities, and accept input for a series of switches, send output to device or relays. So before the PLC, one of the means for controlling the machine was use of power relays and their associates and controls relay. So, if you can see this is the board before controlling the machine before the PLC is not yet started. So the disadvantage of the relay control system are complexity, costly, so hard wiring. If you can see this one, so very hard to wire. So logistic nightmare. So troubleshooting problem. Just imagine if one of relays here malfunction, so it's very difficult to determine which is the relay. Where is that relay? So strictly maintenance routine. So it is not easily to modify and others. So that's the industry before the PLC. So based on history, PLC was introduced in late 1960s. First commercial successful programmable logic controller was designed and developed by Modcon as a relay replacer for General Motors. So earlier, it was a machine with 1,000 of electronic parts. So later in 1970, the microprocessor became reality and greatly enhanced the role of PLC, permitting it to evolve from simply relay to a sophisticated system as it's today. So Modicon nowadays is neither electric. So in building the PLC, the initial concept are easily to program, not need rewiring the control system if change the program. So it's to be a smaller size, cheaper and high reliability, simple construction and low maintenance and cost competitive. So what is the function? The function of the PLC can control the sequential control, the advanced sophisticated control, and the supervisory control. So in the sequential control, it can control the conventional relay control logic replacer, can do the timer and counter, PCB card control replacer, semi-auto, manual control of machine and processes. In advanced, sophisticated, it can do the sequential control and also the arithmetic operation, the information handling, analog control, the temperature and pressure, the PID, the proportional integrated derivation, servo motor, and stepper motor control. So in supervisory control, it can do the sequential control and the advanced sophisticated control, plus the process monitoring and alarm, the fault diagnostic and monitoring, interfacing with computer by means of RS-232C or 422. Now can use also the LAN internet. So also ASCII interface, the factory automation networking, so local area networking and wide area networking. So factory automation, FA, flexible manufacturing system, and computer integrated manufacturing. So the PLC sizes can compose of small, medium, and largest. So it will vary on their input and output, the I/O. So in the small covers unit with up to 128 I/Os and memories up to 2K bytes, capable of providing simple to advanced level for machine control. So in medium, also plus it add the I/Os to 2048 and memories up to 32K bytes. So in large, the most sophisticated units of the PLC family, they have up to 8,192 I/Os and memories up to 750K bytes. So can control individual production process or the entire plant. So so the type of PLC construction. So this one you can have the compact PLC, the modular PLC, the plug-in card. So the manufacturer can be Omron, Allen Bradley, Keyence, Mitsubishi, the Nice, Siemens, Toshiba, Festo, ABB, and others. So it is a hardware constructing or mounting system of the PLC that provides the means of physical connection to various hardware components of the PLC system. So the PLC hardware construction or mounting system can vary from one PLC manufacturer to other or can also vary depending on the type of the PLC used. So sometimes this one, they in each brand they have their different naming of this construction. So sometimes this one plug in, it is a rack mounted. So they have their different. So for this presentation, we will use the compacted PLC, modular, and PLC plug-in card. So this is the types of the PLC construction. This is a compacted, it is very small, and it is one unit only. So a PLC, this system provides the means of physical connection to various hardware component. Sorry. It can the application is not required a lot of input or output. For example, the car park barrier. This would not use many input output and would only require a simple program. So you can use the compact PLC. So it's very few output and inputs. So next we have the modular PLC. So this modular PLC are the system that can be slotted together. So it can be slotted, it can combine. So the basic module contains the power supply, which is this one. If you can see my cursor, power supply. This one is the main module or the central processing unit. Oh, sorry. Sorry. So if you can see this one, this is slotted. So you can put also I/O. So input module and different types of, for example, this one is communication module. So the amount of input and output terminal can be expanded to cope with any changes of the hardware system. It can feature fails, then only that if the features or modules fail, this part can be changed easily and it is cost saving. So if this one is failed, you can change this directly. So the last type of construction is the plug-in card. So others, this one is called the rack-mounted PLC design. So if you can see this one is a rack-mounted, so you will put or you can put a module and this rack-mounted. So it's easily to insert. So the design characteristic of a rack-mounted system are very similar to a modular system. However, these modules are the standard card which slot together into a rack inside the control cabinet. So control cabinet. So this module communicate by a rack. So it communicate by a rack. And then the advantage of the plug-in card PLC, they are easily modified or expanded. They have the I/O points that any other type of PLC can insert any type of points types of PLC. If any features fail, then only that part has to be changed. So can change easily by removing the parts that it is not working. Okay, so what is the advantage of the PLC? So the advantage of the PLC, they are programmable. So up to 1,000 times, depend on the brand of and memory of it. So solid state switches last much longer than relay. So complex logic can be easily represented. Multiple devices can be embedded in one unit. So it can easily be scaled up or modified. So a smaller physical size than hardware solution, easily and faster to make change. So PLC has integrated diagnostic and override function. So diagnostic are certainly available. Application can be immediately documented. Application can be duplicate faster or less expensive. So if you want to create another machine, so it is very easily to duplicate. So connection between switches output can be modified through software easily. So so next, the troubleshooting is easier and faster. So ease of maintenance, less downtime. So easy to develop programs by offline simulation. Less amount of space needed since it is a very small compact module. Changes are easier and faster to implement. So integrated diagnostic. So input and output are easier to monitor by HMI device and from PC. So later we will use the HMI as a replacement of the input in our software. So can stand severe environment condition. So can stand. So I think depend on the PLC brand, they can the highest that I know, it can stand at negative 70 degrees to positive 70 degrees Celsius temperatures. So cost effective and control complex system. Computational abilities make possible more sophisticated control, and reliable components make for a long uptime before failure. So of course it has an advantage, it has a disadvantage. So most of the PLC manufacturers offer only closed architecture for their products. So it is not easily to swap the each brand of the PLC. So PLC devices are for variety, which means the parts and from one manufacturer cannot easily be used in combining with parts of the another manufacturer, which limits the design and cost. So subject to a limitation imposed by semiconductor-based system. So setup and training costs could be high. So it is not easily to change the brand of the PLC. If you have a machine that it is using a Keyence and then you will ship it to Omron, it's very difficult because you will reprogram all the program that in the Keyence, in your Keyence brand. So it's very difficult to change the brand. Okay. So the next, the next is the hardware components. So these main PLC hardware components are found in all PLC systems, regardless of manufacturer, type, and size. There are essential hardware elements that make up every PLC system. They have the 6 hardware components that make up a PLC. So number 1 is the processor, 2 the mounting system. So if you can see this one, the mounting system, and then the input and output interface, the communication interface, and then the programming device. So the processor is also referred to the PLC controller. So in the PLC, the CPU is responsible for controlling all the PLC activity. This include program scanning, such as ladder logic, program execution, handling data storage, directing data flow, and controlling communication among the various interface. So number 2 is the mounting system, provides the means of physical connection of the various hardware components of the PLC. So provides all. Can vary from one PLC manufacturer to another, can also be varied depending on the type of the PLC used. So it will be depend on the brand of the PLC also. It's not all the same. So each brand, they have their own mounting system. So number 3, number 3 is the power supply. The main purpose of the power supply is to convert the available power supply voltage into a voltage that is usable by the PLC processor and other PLC modules. So you need to have the power supply so that you can power all the modules connected to your mounting system. So number 4, the input and output are generally connected to the field device and terminal strip. Communication modules with the field buses protocol like Ethernet IP, Profinet, can also be used as the PLC input and output interface. So you can use a different module. For example, this one is a mounting system that the input and output is connected to your processor. So you can also use another module that input and output and then connecting to your communication interface. So it's a different module also. So your communication is through Ethernet IP or the Profinet. It depends on your design. So number 5, the communication interface has the communication port, this one. So they have the communication port which allows cable connected to a device as other PLC, remote I/O, field buses, touch screen, programmable PC, and server. So multiple communication interface may be required for a larger and more complex application. So the programming device, so you can program your PLC with a PC-based software, or handheld programming device. So nowadays, mostly PLCs are programmed with PC. So it's a PC na. Hindi na siya yung parang pendant lang. So, okay, let's so now we have the types of the PLC input and output. So we have three types. So the the relay type, transistor type, and the triac type. So the relay type is the basically relay concept. The transistor type is transistor type concept, and then the triac type is the AC input and output type. So once we are talking with the input and output. Of course, we need to know if our input and output are NPN or PNP. So mostly here in Southeast Asia, based on my experience, we are always using here NPN type input and output. But if you go to the Middle East area, they are using PNP type. So that's the difference. So let's start. So the PLC structure. So we have the four basic components: the input interface, the output interface, processing unit, and then the memory unit. So the input interface disconnects to the outside input device where they give input signal. So the output interface disconnect to the outside output device where they controlled by output signal. So processing unit, this process or run the programs. So the memory, the processor memory store the user program, IO data, timer, and counter values, analog values, and any control constant that the programmer creates. So next is the structure. So we have the input interface going to central processing unit. And then if they have a calculation or arithmetic operation, go to the memory unit, vice versa, and then going to the output interface. So this is their programming devices. So you can store your whatever the program that you created to your central processing unit. Okay, the program execution. So the program execution cycle. So we have the start and then the scan cycle, input scan, program scan, and then the output scan, and then the housekeeping. So the PLC program execute as part of the repetitive process referred to as scan. A typical PLC scan start with the CPU reading the status of inputs. Next, the application program in executed. Next, the CPU performs internal diagnostic and communication tasks. So finally, the status of all output will updated. The process is repeated continuously as long as the PLC is in the run mode. So we have the start here. So you can see this one, internal inputs. It's written to the input image. So then program scan. So then output scan, and then the housekeeping. So that's the cycle of the programming in PLC. Okay, so next is the input, different type of input and output. So in input, we have the switch and push button, sensing device, limit switch, photoelectric sensor, proximity sensor. So conditioning sensor, we have the pressure switch, the level switch, temperature switches, float switches, and encoders. So next is output. So can derive the output by means of bulbs, motor starter, solenoid, actuator relays, horns and alarm, stack lights, fans, counter, pumps, and printer. So this is the kind of output that the PLC can drive. This one is only example. So now we are on the programming language. So most common language encountered in the PLC are the ladder logic, functional block diagram, the sequential control chart, or the Boolean and mnemonics. So mostly we are using the ladder logic. If you are on the highest programming stage already, you can use all programs. But in this representation, we will use only the ladder logic. So if you can see the difference between the sequential function chart, the ladder logic, the mnemonics, and the function block diagram. So in the sequential function chart, it is a chart. You will program your PLC as a chart, in ladder as a ladder, and in mnemonics as this one, and the function block as the function block. So we are only focusing on the ladder logic in our presentation. Okay. Okay. This is basically the ladder diagram. So we have the line 2 and then the line 1 and line 2. So we have the input module and then the output module. In our ladder, we have this same as representation. We have the line 1 and line 2. So to complete the signal, to complete the circuit, you need to complete all the requirements here so that our M or coil will be operated. Okay. So the PLC resolved the logic of the ladder diagram rung by rung. So from top to bottom. So the execution will be top to bottom. So usually all the output are updated based on the status of the internal register. Then the input state are checked and then the corresponding register are updated. This process is run in endless cycle. So it will run endlessly. Okay. So if this one, rung 1 to rung 3 already processed, this one's called the scan time. So you complete already your one scan. So okay, yeah. So next. So what is the ladder logic? So the ladder logic, the device that controls the logic function of a control system are physically wired. This is called the hardwire logic. So hardwire logic is done by using relay ladder schematic. Control SIM and then the associate control element are represented between two power lines. We have the line 1 and line 2. So all control elements are placed in a ladder-like function between the two power lines. So the PLC logic function can be similarly represented in a ladder logic diagram. So major difference is that the hardwire logic can only be modified by rewiring and change element as needed. The PLC control function depends on the logic states and the outputs, and these are very easy to change through the software program. So in this representation, we will only talking on or off. Our program is on or off. So once we tell on, it is true, normally open, contact close, or energized. Once it is off, it is false, normally close, contact open, or de-energized. So do not confuse the internal relays and the program with the external switches and relay. So internal symbol are used for programming. External device are provide actual interface. So for this key and branch, we have the internal relay such as R, RMR, LR, like that. So the next page is the ladder diagram. So the ladder diagram. So this one is the relay schematic. So if you will see this one, if you are a wiring guy, so you will see only this one. So in the software, it will be ladder logic program. So it is equivalent to logic gate A and B. So this one, Y will be on if the A and B is satisfied. Okay. This is the ladder logic. So equivalent ladder logic. So this one is the logic gate. So remember, we will only focusing on the ladder logic. So ladder logic or logic. So this is the relay schematic. So switches, and then this one is AB. So we have two switches connected in parallel and used to control solenoid valve. For example, this is the solenoid valve, the Y. So we need to satisfy at least one of these conditions to on the solenoid. So this is the logic gate equivalent. So now we are on the combination and or logic. So this is the relay schematic. Two limit switch connected in parallel with each other and in series with a pressure switch and used to control a solenoid valve. So at least A or B is on and C is on, or Y will on. So this is the equivalent in logic gate. Okay, so we will focus only on the ladder logic. Our software will focus only this one, ladder logic. So our sample application, motor control circuit with the two start-stop button. When either start button is depressed, the motor runs. By use of the seal-in contact, it continues to run when the start button is released. Either stop button stop the motor when it is depressed. So for this one, so since this one is contacted, it's a normally closed, right? This one C is normally closed and D is normally closed. So A will be normally open since this one is our switch. So if this one is started, if you press the A, motor will start and then our internal relay M will be hold that signal so that it will be continue. Okay. Remember this one is a representation as L1 and L2. To complete the signal working, you need to satisfy all this condition. So this is the logic gate. Okay. So we are on the PLC instruction. So we have the relay, the timer encounter, program control, arithmetic, data manipulation, data transfer, and others such as sequencer. So relay, consists of two parts, the coil and then the contacts. If it is on the output, it is a coil. If you're using it as an input, it will be a contacts already, okay? So coil and contacts. So this one is the PLC instruction. If you can see this one, it is, if you will code this one as LD, load. So create a normally open condition as the first condition of the bus bar. So this one is coil, this one, this oval, it is coil. So this condition will be LDI, so load inverse. So it is a normally close. Oh my, wait, okay. It is a normally close. Okay, this one's normally open. So create normally close contact as the first condition of the bus bar. So this is the first bar. So if they have other condition on this first, so you can code it in the software as AND, A and D. So it combines a normally open condition in a series with the previous condition. So if you code the normally closed, it is an E, okay? And then if this one, you will code it as OR, a combination of normally open condition in a parallel with the previous condition. So next, we have the normally closed OR. So you will code it as OR I, or inverse. So and B, this one is block. So combines two group of condition in a series block. We're adding a complex program structure in a series. So same as in OR B or block. So combines two groups of condition in a parallel blocks for adding a complex program structure in a parallel. So this oval or circle is the out. So output is specific that an out bit has to turn on execute. So driven output coil. So this one is the coil already. If you can see this one YMSTC, so this one you can use. So the special function out, an output which only used for a specific function. So we have the PLS and then PLF. So this one is the false rising and false falling signal. So next we have on the connection instruction. So if you can see this ladder, so it is a latching. So we have load X0, and then you already have the coil Y0, which is the output. And then this one already you contact this, or you put it as an OR to your X0. So this one is the coil, and then this one is the contact. So remember last time we have this one. So relay consists of two parts, the coil and then the contacts. So the contacts. So we can use our coil output as a contacts. But be very conscious. We cannot use YC if we already use Y0 as an output. We cannot use the address Y0 again. So it is prohibited to use a double coil or double address output. So if you use Y0, you cannot use Y0 anymore. If you did it, your program will be in an unwanted scenario, or you cannot control your Y0N. So next is the multiplexing. So we have the input, and then you can multiplex it to different types of address. So three types of address. So Y0, Y1, and Y2. So it is a multiplexing. So next is diverting. So you will divert an internal memory. So we have an input, and then you have an output coil, internal memory, and then use the internal memory to drive the output coil of Y0. Also, if you do internal memory coil, you cannot use also this address. So it is only, I think, only one rules. You cannot be double coil. Okay, in PLC programming, you cannot be a double coil, or else your certain output will be give you a different output or different scenario already. So we are already on the special program. So timers. So it creates. So it creates a 0.1 seconds decrementing timer that is started from the set value when the execution condition turns on. So when the SB has been, has been timed out, the completion plug is turned on and time driver event delay. So for example, I press my input or X0 for 10 seconds, then my output Y0 will turn on. So it's delaying the turning on of my contacts Y0. But if I press it only for 5 seconds, it will not take an output. So, so it cannot, so I need to press it for at least 10 seconds so that the T0 will be activated. Okay. So next is the counter. So counters counts down the number of times of input condition turns on. Which time the input condition turns on, the present value PB is reduced by 1, and when the out reaches 0, then the completion plug turns on. So same here. So if I will press 1 in the input X0, so my Y0 will not turning on. It will not turn on unless I will press it 2 times. So I will press 2 times so that it will this condition will be turning on. So to satisfy. So C0 will turn on. So remember when you use C0, since you are saving the value of this counter, so you need to reset the 0 to 0. Because every time that I will press the X0, it will count. It always count. Okay? It always count. So possible, this one C0 will be 3, but this one is already activated because your condition 2 is already satisfied. So, okay. So next, maybe in our demo program, we can see that one. So another special function will be set and reset. So if you can see this latch on output coil, so canceling the holding operation. So reset latching on output coil, canceling the holding operation. So canceling. So for example, I have this input. My input is here. So for example, I press this one is X0. So my output will be set. So it will be 1. So my output will be 1. Okay. Since it is 1, so when I press reset, here, my output will go to 0. Again, when I press set again, since my condition is reset already, so my output will become 1. So it is already set, and then reset. So that is the set and reset. So the very important function, special function, is the pulse rising and then the pulse falling. So this one is only scanning one period is on. So for example, your scanning is only for 0.4 milliseconds. So your input will be turned on only for a certain period. For example, 0.4 milliseconds only. So even though your switches is still on, your output in your program will consider only one cycle. Okay. So this one only. So even though that this one is on, okay, see this one, huh? So my output is this one. So 1 is 1. So it is 1, but my rising input, I can get only this one. A few seconds only, or no. So milliseconds only. A few milliseconds only. So it's a few milliseconds only. So even though that this one is always on, so I can get the signal of this one with a few milliseconds. So same as when my program is turning off, so it give me a signal for a point milliseconds only. Okay, so even this one is always off. So my signal will give me only a few. It's like a click, a blink of an eye, like that. So if you can see this one, so this is my output. It will on, so it will give me this one. So this one is the false racing. So when the output is falling, so it gives me also a signal. It's like a blink of an eye, or it's like one scan. So okay. So the end program, logic end program. So okay. So we are on the sample program. So in our maybe here we will do the software also. So I will share my software. I will stop this, and then I will share my software. So okay. Our sample program. So design a ladder diagram that output Y0 will activated only after pressing switch 1 and switch 2, and will be turned off by switch 3. So since we don't have any internal switches, so let's try to create it on HMI. Okay, let's start it. So this one, we are using the software for keyends. So we will try to create a switch here. So switch. So we will name it as, so the address, let it be like this, or maybe we can put 100. So we will name it as switch 1. Address is 1000. So this one is the last 2 digit will be the bit. Okay. So every brand or software of different brand, for example, Omron, Keyence, and others, Siemens, ABB, they have their own different type of properties, but the same idea, or if you have an idea how to create it, it will be the same. Okay, so this one is the switch 1. So by the address of this, so please let me, and then so have control C and control C. This one is 2, so we will change the address. So we will change it as a bit 1. So the last digit, it will be the bit. Okay. So and then we have our switch, control C, control V lang. Then switch 3, and then this one will be the switch 2, bit 2, switch 3. Okay. So 3. So the condition here is set momentary. So since I don't want a momentary, I want it to be as in the reverse. So this one, I will put it on the reverse. So once I click, it will reverse whatever is output. So this one may be set momentary, it will be good. So I will set only like a pulse or triggering it. It's like triggering it only. And then the output lamp. So style. Okay. So I will put it as, remember we don't need, we should create it as a unique number. So or 200, for example, 200. So, okay, start. And then our program. So our program will be like this. So we have our switch 1 and switch 2. So I put it as 1, so I need to change it as all right. Or no, 300. So we will change it the HMI instead of this one. I will change the HMI. So I will change it as 200. I will change 200 and then bit 1, and then this one is 200 bit 3. The last 2 digits will be the bit. Then the R lump will be 3000. Okay. So the will be 2. Then will be 2. Then will be 2. Okay. Then let's start this program. So if you can see, switch 1 is 200, and then the last bit will be the bit. The last 2 digits will be the bit. So switch 1 and switch 2 will be satisfied, and then my output R will be activated. So I will use the internal. So this one is output, and then I will use it as an input. So coil, and then the contacts. I will put it as a contacts. Okay, let's start to simulate. Oh. Start simulate, then this one. So this one is only the file of my PLC. So I start simulation. This will wait for a while. So we are simulating it. And then we will create this one. We'll go this one if you can see it. And then I will run, and then I will simulate, and then I will press this 200. So if you can see this one, so it is a representation of our switch here. And then if I will press again this one, so our lamp will operate. Okay. So for this one to deactivate, I need to click this one. So, okay. If I press this one, it is stop. But if this one is I holding the switch. Since this switch is only a toggle switch, so when I release this one will be on again. Why? Because our switches is in the holding switch. See it? It's still on hold, right? So if I will press this one, it will be reversed. So So if I will press this switch 3, now our lamp will off already. So because we put our switch here as a reverse bit. So see, um, one more. If you can see this one, I will change it to set momentarily. And then this one set to momentarily. See the difference, This program, so I will simulate again. Wait, just hold. So wait. So this one. So earlier, once I press this one and then I press this one, it will ghost an output, right? It gives us an output already. But since I will set this condition as a set momentarily, and then this one is set momentarily, so when I press this one, and then I press this one again, nothing happens, right? Right? So now, if I press this one also, nothing will happen. Because I set this switches as a momentarily only. It's like pressing it, and then after pressing it, it will become off again. So how can we solve this one? After pressing this one and then pressing this one, our switch will activate. Okay? So we will do it as go to simulator edit. So we will edit our program. Okay? So since this one, I will insert another. So I will put this one, Control C, Control V. I will save this signal. So maybe I can use set or reset. Set or reset or latch. Okay. So if I will use set M0 or set M200. So if you can see it, this one 200. So I will put it this one. I will change it as M200. Okay. So since I use the set, so I need to reset this one also. So I will add another. So invert. Okay, let's try it first so that you know it. So simulator. Okay. See this one? Maybe you see it. Okay. So when I press this one and then I press it again, so it's already on because I already saved the signal of switch 1. So since now I cannot even so the condition now, since this one already saved the signal, so if I press the switch 2, it will on again. So since this one I need to reset this one so that our condition will, okay, so I need to reset. So because here you can see every time that we click switch 3, it will off, and then click the switch 2, it will on. So our condition is not meant, right? So it because design a ladder diagram after pressing only. So now we should reset. So we should reset this one. So go again in the simulation editor. Insert empty RAM. So easily I can cut and then I can paste and then I can delete and then I can delete this one. So I can do is I can load R200 and then the bit 2, which is the reset or the switch, and then I can reset M200. Okay, so I will reset 200. So if I will go to simulation, it will work already. Sir, hindi nakita. Sir, ito. Ano po? Okay, simulation natin. So after pressing this one, right? So I will reset. See this one. Ay, see this one, the reset M200, if I press the switch 3, okay, so already reset, right? So even though that I will press the S2, switch 2, nothing will happen, right? So, okay. Okay, that's the sample number 1. So also, in this simulation, if I will press 2 and then press 1, it will not work again because I never saved the signal of switch 2. So we need to do same. So we need to save the signal. Or you should replace the status or the status of your switches here. If you have an electronic or actual switches, maybe it's not will be toggled or it is permanently on and off. It's not a toggle switch. Okay? That's the number 1 sample. So, Sir Jan, gusto mo mag-break muna?
Okay guys, let's have a 10 minutes break for a while. Refresh muna si si Sir Argel. Napansin ko nag-harsh na yung boses niya. Let's have a 10 minutes break. For this, let's come back ng 2:37. Okay? Thanks guys. Sir?
Hello, sir.
Okay.
Dinig po ako.
Dinig ka.
Mute lang mo, sir. Yan, sir. Dinig ako.
Yes, sir.
So, okay. Okay, let's start up. I think I need to show it first to you. This because this type of instruction. Okay, so maybe we need to first do it first on the PLC, so that we can make a new, or we can create let's first create this instruction before we go to the sample program. So we will create the load-D, and D, okay? So new, for example, so if I'm a first timer or I'm a beginner, this is the actual screen of my software. You can see it. Okay, so if I want to insert an instruction, for example, I want to load here. I want to input here, so I will put LD. So address of my switches, for example, X0. No, not valid. In Kian's not valid X0. It's different type. So for example, 00. So remember the last 2 digit is the bit. Okay, so I can comment it. For example, X0. Okay, and then if I want an output, I can directly type out. So out, example, R300, 00. And then comment. So I can comment it as Y0. Okay, so that's it. So if I want to OR this one, so I can put, for example, I want and E. So R2, so 01, invalid because it's not load I. So different brand, different command execution. Just this be remember that kind of ano. So should be and, but this one is load I. Okay. So if I want to convert it to mnemonics, I have here. I cannot convert it to no. It is prohibited here. So other type, you can convert them as mnemonics. So remember last time the 4 types of programming the PLC. So one of them is the mnemonics list. Okay, so that's it. So if I want to OR here, I can type OR. No, this one is different. Already giving me. So I can put it here. So I have a icon here on the top. What you can see. This is the icon of instruction. Okay. So we can put another switch name R200. So bit 02. Okay, that's it. So how to command in this software. So, so let's back to our sample. So I will close this one. No. Okay, back to our sample. So this one, this application, so it is easily to change in the software. For example, you are on the already on the production, and then your switches is have a different type, and then you want to use it since it is prohibited in production to have a lot of downtime. So whatever the available you should be used on it. So if you have switches, a different type of switches, and then you can directly change your program. It's easily and faster. Okay. So the problem in, for example, in production, you have a PLC type of NPN, and then the available switch or components that you have on your material houses or in the house. So you cannot do anything on the program. If your PLC is PNP, your switches should be PNP also. Okay. So if your NPN, your stocks is NPN, so you need to convert it through electrical diversion. You cannot put directly the PNP switch to NPN PLC. So it will not work. Okay? They will not work. Okay. This is the, so if we want to change this program also, example, I want to change this one so that the R2 will be same as in the switch 2 will be same as switch 1. So I can go to simulation. So I can edit it here. So I want to insert. So I can copy direct, Control C and Control V. So it is user friendly. So don't worry. So I can change it only this one. So I will change this one as 1. And then I will change this one as 201. So remember, we don't want to have a double coil. Okay. So since I set this one, so I should reset it also. So Control C and then Control V. And then I need to complete the program only or the wiring. Okay. So when I will start configuration, see so if we want to start the simulation now, then display. Once I press the switch to, wait. So I will press the switch 1. I switch 2 and then press switch 1. So why is not happen? Why never on? So let's see. Okay, switch 2. Because we never changed this switch 1 to this one, right? So we need to change this ladder also to, so we need to put this coil as an input of the our output. Okay, so I will change this one. So MR201. Okay, so I will start the simulation again. So what I'm doing here is I'm setting this this signal, and then we'll put it here as a form of diverting it. So let's start. So reset. So I will press the switch 2, then switch 1, and then it's on, and then reset by switch 3. So okay, so whichever the first, our lamp will, why we never, because we never reset. Okay, so we should reset it as 201. 201. Start again. So easily to troubleshoot, right? Okay, simulate. So reset. So first is switch 1, and then second switch 2, and then 1. Then our lamp will on, and then reset. So whichever will be the first, this one will work already. Okay, so that's it. So since our representation of our switches 1 and 2 here is a toggle switch, so they are not holding the signal, so we need to set the signal first, or to save the signal of the switches, switch 1 and switch 2, so that our output will go on. Okay, so you can save your signal by means of set and reset, or by means of latching. Okay, so this is the answer to number 1. So in our representation here, our the answer is like this because this is a tag. We put it on the representation of our HMI. Our switches is reverse bit. So it will reverse whatever the status of the previous status of that bit of switches. Okay, but if it is a set momentarily, it will set only a few. It's like only a clicking it, and then the signal will lose already. Okay. So number 2. So number 2, so we need to design a ladder diagram that output Y1 will activate after pressing switch 1 twice, and will be deactivate automatically after 10 seconds. So now we were using the timer and then the counter. So we will use, so after pressing, so our condition, the condition of the switches, switch 1 here should be a toggle switch. Yeah, it's set momentarily only, so it will not hold the signal. It will set only. So if here I use a special function of pulse rising, so I want to use only a few signal to count this one. So later we will remove this one so that you can see the what will be the actual function or the response of our PLC if I will remove this one. Okay, so let's start. So this one is 2, so I will put this one close, and then I will revise it. So I will go to our HMI. Since this one is switch 1, switch 2, so I will put a representation. C, Control D. Oh, sorry. So this one belong to here, so I will put rectangle here. This belong to here. and then no, that's here. Maybe this one. So we will close it. This one. So this one is the example one, and then this one. Okay. So I will put this one 4, and then 4 is so 3, and then switch 5, and switch bit 4, bit 2, and bit 1. Guys, since we don't have an actual input, we are using the HMI to simulate our program. So we are representing this one as a switches, since we don't have an actual actual input for switches. So this one should be Y0. So I will press this one. I will put this one as 1. So bit 1. So, okay. And then okay. So in our program, remember, so question 2, we are in question 2. So I use this one. So I will remove it as, I will edit, simulate. So it is a bit 4, 3, right? It's a bit 3. So my representation here is a bit 3. Should be bit 3. And then switch 5 is bit 4. Okay. So I will put it here as switch 4. SW4. Okay. So I will start. Start simulation. So here I will start this one also. Simulate. Then my program. Then start simulation. So why it is open already? So since it is open, I will stop first the simulation here so that it will off. Okay. So now it is open, T0. So let's T0. So why it is? So I need to reset T0. So first I want to reset here. No. Let's start. I will try to reset. Okay, I will reset it here. Okay, reset. Then see this one. So here, so I will press. Look on this switch 4. When I press this one, so you can see it already count by 1. And then when I press it again, it already pressed by 2. Okay. So our condition should be reset by T10. After T10 will be reset. So now, why never reset? So reset by switch and then 1, 2. So this one never count. Why? So this one should count. Reset 2. Never count. Oh. The counter never works. So maybe I will edit it and then close. Then again here. Then put it here and then what I can do, I can use this one, load R20001 to count this one, and then I will change it by hundreds. Right now I put it as 10, override. So on to timer. Timer 1. Okay, let's check. Close. So let's try. So let's try. Reset. 1, 2. So now it's counting, right? Already counting. So I need to reset the. We never reset because the T100, we never reset this one because I never changed the T0. So I will change T0. So I will change T0 to 100. So because we changed the timer number. So simulator. Oh, it will work. So if you can see it here in the middle, so I will press the switch 1. So it's already counting. So 2. So okay. So it worked already. So 1, 2, and then it worked already. Okay. 1, 2. So after I press, it will work, and then it will count by 10 seconds. Okay. So that's it for the number 2. So if I will change this one into a normal output, so I will change to a normal. Let's see what happened. So I will change it only here, then press enter, then simulator, and see. Let's see what happened. Okay, and then I will press the switch 3. So it will work also. Okay. So also. So see, so when I count what, press 1, press 2. Okay. So that's it for the. If you can notice, if I press this one, if you can see the blinking, right? Did you notice that when I put it on the false, you can see that one? Anyway. Anyway, that's the difference. This in this program, there's no quite significant change, but others sometimes you can encounter when this is pressing, a lot of counting will be made because the scanning time is already it's like the scanning time, and then you're still holding it, and then it will count again. It's like that. This will depend on the scanning time. Sometimes you need the pulse rising. Okay, that's the number 2. So basically here we changed it only the timer address. Oh, why it is? Because I have already T1. That's why when I change it to, oh no, this one I will remove this one already. I should remove this one. Plc Control B. Why? Because we don't have any more T0. Delete. So delete wrong. Okay, so that's the number 2. So let's go to number 3. And then the last number 3 and then number, basically this one should work. Sorry. I don't know why now. So number 3, design a ladder diagram that output Y2 will be activated after pressing switch 3 and will be deactivated after pressing switch 3 again. So switch will be in the toggle state. So I think should be this one is 4 because I already, oh no. Okay, so I will create another switch in our HMI. So I will first compacted this one. So okay, then I will Control V, and then this one. Then I will create another switch. I will name it as a switch 5. Address is 5. Then I will put it as a switch 6. Okay. And then this one is lump, and then this one, I should not have a double coil. So 2. So I can put also a name here. So lamp 2. This one lamp 1, and then lamp 0. Okay. So this one should be on the toggle. So set momentary and bit 6, bit 5, switch 6. Okay. So start simulate. Then the moment question 3. So we are here. Okay. So let's try. So switch right. So it's so I will change the switch here. So I can use the editor also. Okay. 5. Yes, 5. So 2. Yes. VM 3. Let's start. Simulate. So our simulation window. So here, so when I press this one, nothing happened. Why? Because this one I never change. Or switch I never change, sorry. 5, 5, 5. Okay, let's start. Okay, and then let's try. So I need to play and start. So on, when I press this one, this lamp should be off. Okay, so on, off, on, off, on, off. So I think in this example, the false command will have a significant in the output. So if I will remove this one, let's see what will happen to our program. So I think it will have a significant change if I will remove this one. Okay, and I will remove this one. And because this one is our switch, one only can, I think, can then start simulation, then you'll see. And then play. I need to play this software, and then let's see. Let's see. So when I press this switch 6, so what happened? Never, right? Sometimes it on, sometimes it off. Okay, so it give us an unpredicted output. So that is the significance of false rising. Okay, so see, I cannot control it. Even if I will change this one to a normal, I cannot control it anymore. So, or give me an precedent and cannot controllable. Even though our logic is good, but since the program, we are not using the pulse rising, so electricity is flowing all through the ladder. Okay, so that's the significance why we have a pulse rising, so that the electricity will not flow here in through this rung. So once it is detect it can detect the signal or pulse, it can on this one, and then that's the use of the pulse rising. So parang hindi nakababad. It will not hold the electricity longer. It's only seconds. So that's the significance of using the pulse rising and pulse falling. So let's sit back to what is original. So I will change it to now. Guys, this one will work, right? It will work, right? So I will change it to falling. See the difference, huh? Okay, before we will change it here, I will let's show it again. What is how it is work? Okay, so it is rising, right? Rising. So the electricity from 0 to 1, it will give me a signal. Okay, so once I press this switch 3, look the switch 3, I will press it. I should run this one, Don't forget to run the software. So when I press this switch 3, so, and then off. So look this one. So when I press, so now my mouse is pressing this switch 3. I never release it. the lamp is already on. So when I off and then I press it again, that's the time that it will become off, right? So now we will change this to pulse polling. So see the difference, huh? This one, see the difference on the, so I will put simulator. So I should run the software. So once I run this one and then see, so see the significance change. I will press the switch 3. Nothing happened, right? Nothing happened. I already press it. In the false rising, once I press, the lamp 2 will already on. But this one, since I'm still pressing it, there's nothing happened since our command is polling. So when I remove this one, that's the time that I get the signal. Okay? Understand, huh? So that's the time that I will get the signal. So once I press it again, once I release, that's the time that I will reset it. Okay? That's the difference between the false falling and then the false rising. Okay? Hope understand. Okay, yeah. Okay, that's for the question 3 of our presentation. Okay, so now for our sample application, this one is our sample program. So we can take a scenario that we can create a program, a sample application program. That's the works will be, or in the operation will be in the sequence. So first, the scenario will have, the scenario should have a work object, a start button, a cylinder down, and then a down confirmation sensor. So a test start, and then test stop, then cylinder up, and then the machine standby, and it's already end. So let's say that this sequence, it is a test machine, and then it is putting a adhesive or putting a glue on a product. So we are putting a glue on a product. So we will put a, you should activate your imagination on this one since we don't have any visualize. We should visualize it as we have a machine and then we are putting an object, and then once we start or press the start button, our cylinder will go down, and then the sensor for cylinder down will confirm that it is down already, and then you can start the test or putting your adhesive. So after for example, 100 seconds, it will stop, and then the cylinder will go up. Okay, and then your machine will be ready for next cycle. So guys, this one is a one machine application only. It's a very simple application. Okay, let's see it is. So let's create our imagination. So we will create. So since this one is finished, I will put it here, and then this one should be put it here. Okay, let's say our representation is a machine. Machine. We will create our imagination here since we don't have any actual device. So our machine is like this, and then you have up and down. Okay. So I have a switch or lamp, a representation of cylinder. This one is a representation of my cylinder that is going down. So I will put it as going down, and then I have a push button. Okay, I can copy this one. Control C, Control V. So switch as a start. Okay, and then I changed switch 7 since we don't want to have a double input also. So for example, we have also here a process, or this one is already on process, Huh? So, and then we have a sensor. So Control C, Control V. So remember, maybe our sensor is a photoelectric sensor that detecting the parts presence. If have a presence or not. Or if you have already a part or not, no part. So it will be switch 8. And then work detect. Okay. Uh, So after this one, we have work detect, and then this one sensor also that check if our cylinder, this one is our cylinder is going up and down. So it is run by a solenoid valve, and we have, for example, a switch here. It is set momentarily, and then we will name it as switch 9. Switch 9. Yes, double 9, and then so it is work detect. So it's a limit or read switch. Okay. So limit switch, and then we start up. Okay. So we will represent this one as Control C, Control V. So the sensing of this one will be here. Okay, let's imagine we are sensing the parts here. For example, and then the limit will be Control C, Control V. The limit should be here. For example, the cylinder is already down. So the switch will be here. The switch will be here. Okay. And then this one is our cylinder. So our work object, start, cylinder down. So cylinder confirmation, which is the sensor or the limit switch. Okay. So let's try this one. So up this simulation, then start. So for example, start 7. So I will put it as, I will change the numbering from 1. Start is 1. So I will change it as 1. Okay. So see my numbering 1 0 0. Okay. So 1 0 0. It will be 0 0. So this one should be 0 0 2. 2. Oh, 1. Sorry. 1. So I will put it here 0 1 0 2. 0 1. 0. So 1 and this one is the 2. 1. So 201.204. 202, sorry. Okay. And then this one, we'll name it as R3 300 04. Then this one, dump it. So 300 05. Okay. So since this one is the process, maybe we can change the address later. Okay, let's start here. So this one is our application program. So since I change all the address of switches, so I need to change it here. So this one is 200.01, then 00.02. Okay, so I should change this one. Editor. So our application is once I already press the start button and then the presence of parts is on, that's the time that the cylinder will go down. So our start button 00100. This one is the start. So I will put it as start. And then 00101 detect. So 0101. Then detect parts. All right. So, and then T01, this one, limit switch is, we'll change it to 00102. So, all right. So, I will put it as a limit switch. Okay, and then our cylinder is 4. I think it's quite cool. Okay, and then our test start is DM3. So I will change this one as a DM3. So I will change this one. Lump switch, lump bit. Okay, so I will change. This one is 0. And then the lump bit will be D3. So I will find the DM3. So I will put 3. Okay, and then start. And DM3, okay. Let's check it. All right, let's start simulator. So later we will discuss the program if it's working. So start. Let's wait a while. Oh, we need to check our. So this one should be not set momentarily. It should be reverse bit. Why? Because when I put parts, it should be when I click that one. When I click that one, it's like it's already sensing the parts of the object or the object. So I will change it as a reverse. And then this one is a toggle, set momentarily. And then this other one is a set momentarily also. Okay. I will first close this one and then start again. Let's see. Start. Okay. So now the simulation is here and then our program. So I should run this one. So this is the application. Then I will put this one here and then I will minimize it so that you can see the PLC, what is happening. Okay. So we are only here. Okay, perfect, fine. Okay, first I should start the machine when I press this one. When I press this one, the process will not go in because I don't have the parts. For example, I already put my parts, so I will put click. So for example, I already detected it. So already on, detect, I already detect. So I will start. So now it should starting moving. For example, it's starting moving already. Why it is not moving? Because 140 is D2. So I will change this representation as a DM2. So see, let close again. D2. So I will stop first this one. So I will put this representation, or I can put this one as Y3, our output. Sorry. It is 304. So I can put this one as 304 address. So it is 5. So it is 4. So it's my mistake. It should be 4. Start. So again, we will minimize a little bit so that it's already open. Okay, so now it's already open, but so remember our previous sequence already. This one should on, and then wait for the limit switch to make a process, right? So cylinder down and then down confirmation. So we need to have a down confirmation. So down confirmation. So once I click this limit switch, for example, it's already reached its down button. So the limit switch already sends the cylinder that's already on the already go down. So I will press but nothing happened. So because the limit switch is here is okay, I will press this one, switch 5. So see here, I never change this sensor. So I will put this one. Okay. So I will reset. Okay, wait, we will back it here. So 005. So I never change. Sorry, never change it to 001. 2. So what more? Then edit them first. Our switch 5 is So I will change this one as 001. Simulate. So I will remove this again because we changed something in HMI. Address of this one. So I never saw it. Okay. Start. So let's wait. All right, here, then minimize. Okay, let's try. Wait. So play on this software, then start. So now, hope it will work. Then start from the beginning. So the cycle will be, if I press without object, it will not work. Good. So I think this one, I will edit this one. The part detect is 2001. Simulate. I need to play here. Every time that I change, I need to play. Okay, see the button here. Huh? So I need to play. So if I start, nothing happened. Okay, totally fine. If I will put the parts, so for example, I will putting it and then I will click the parts here. So detected. And then I will start. This one should be on. Okay, on. So I should press this limit switch so that this process will start. So why never? This one is already working. So already go up. Why this representation never? Did we change it? Did I change it? DM3. Oh, my. It is 300. So let's M again. Okay, let's try again. So already on. So never. Okay. So now, I will start putting the parts and then start the switch and then working, and then I will press the down button. For example, you already detect the limit switch. So it's already working, and then out already. So because this one is emphasizing that our process is already finished, right? So if I will start it again, it will never start because the process is already finished. So I will remove the parts and then start again. Cannot start because there's no parts. So I will put the parts and then start. So moving, and then, so now, the question now is like this. What if the cylinder never go down? Or since the cylinder is activating through air by the means of the solenoid valve, if our air supply is not sufficient, our cylinder will not go down. So our program, in this program, the machine will already hang on this state. So you never know that that your machine is already hung. So until I press the limit switch. So that's the time that your program will be completed. Okay. So now, how can we modify this program so that once that this limit switch is we never click this limit switch, we know that our machine is already on the state of waiting a signal, running but waiting for a signal. So one easiest way to do it is to have a different alarm signal or a different lamp, and then if this one is not on, it should alarm. Or if in our representation, since we are using the HMI, we can use it as an alarm message. So I will go here, and then I will put an alarm message. So where is the alarm message here? Thanks. Oh no, where is it? Um, Not here. Sorry. Sorry, yeah. I will forget where is it. Oh, good. I think I need to open my other program. I forgot where this one, not table. Wait, DNC, VP, and function, generation, feature. Oh, this one. Alarm display, sorry. Pressure. So I will change it as 90. This way is 9. So we'll show it as a basic only. So I think 5 will be fine. And 6 to text will be 12. 17. Okay, and then we will put it here as a line. So we put it as say 40, 90. DM will be start from say F. I will using say adopt different address. So 00 will be fine. So address. So this one later we will update. So I will update this one. I will update the HMI. So start, simulate. Okay, we have all the screen here. So start. Okay. So every time that our cycle will be finished, we will display a cycle finish, and then once the limit switch is not reaching the down level, or the cylinder is not reaching the down level, we will put a limit switch time over, or read switch time over. Okay, so we will put it here. So let's start simulating again. So we are putting our parts again, and then start. Okay, so now see this one. Start down. Down is already starting. Okay, we have a signal of down already. Then down is test start DM3. DM3, to start DM3, this rang schematic, or this step is waiting the limit switch to turn on this one. So if this one is not turning on, we should have an alarm or a message that this one is still waiting it. So we will put, so I will put it in the editor mode. Is better, much easy. So since this one, so I will put a timer. Okay, so we will put a timer. So Control C, Control V, and then the timer will be 50, for example, timer 50. So it is 150 seconds. Then time of this one is time over. So that we know that we are waiting the limit switch signal. Okay. So once this one operated, and then it's waiting this one, this signal. So once this signal DM3 starts test is already activated, we should cut this timer because we already have the signal, right? So we will put it as a normally close. So DM3. DM3. So now, since I have this timer, so I can put it here. Another, so load T50, LD T50 start. So I will call or out, say F0. Say F0. Remember our address for, okay, I will activate F0 to call the time limit, time over, okay, start, time over. So in our HMI, I will, since this one, say F0, so I will put a message that limits or read switch time over. Okay, so I will start here, simulator. Then here already, I think it's here already. So let's start the PLC simulator. Let's wait. Okay, simulate and then play. And let's see. Okay, so our goal is, if we never click this read switch, this display should have a time limit, time over limit, or what message that we put on the HMI. Okay, let's start. So put a product. Okay, so let's start. We are putting a product. Okay, detected. So detected. Start. Okay, we are starting now, but we are not, for example, we are not clicking the limit switch. we should have an alarm or message here. Why never get 50 time over? So we should have a 50 here. So my fault. See this one? T150, and then I put it only T50. So it's different, right? So I will simulate edit, and then I'll put 150 here. So, okay, start simulation. Okay. See this one, limit switch reads limit read switch time over. So time over. So at least now we know that our machine is working. That is only waiting the limit switch to be on. So once I press this one, this limit switch message will gone. Should gone. So why never gone? Because I will put it in HMI, the characteristic of, what is the characteristic of, what is the characteristic that I put here? So I will check this one. So log display, I should put it a real-time display. So, okay. And then, so start simulate. Let's see. Again. Okay. Okay. It's already, the product's already finished. Okay. So, start. Remove the products. Start. Remove the product. Start to put the product, right? Sorry. Then start. So now, once we never click the, see, already have. So once I click it, click the red switch, it will be gone, and then it will start our process. Okay. So now it's complete. So now we want to put, once this, for example, I need to remind the operator that you should remove the parts because this one is already finished. The part is already finished product. So if I will start, nothing happened, right? So I should remind them that you should remove the products. So maybe I can put cycle complete on this say 02. So I will put here cycle complete. Remove the parts. Okay. So it is 01. So I will start. So in our PLC, I should put say F01. Say F01. So just put edit simulation and insert. So I will put out. Sorry. Control V. So I will put say 1, 0, 0, 1, 0, 1. Okay. So where is the complete process signal here? Okay. Where's the complete process signal here? Where's the complete process signal? Nothing, right? because this one is a start burst, but there's no complete. So we will create a complete signal. So empty. So we will use this start. So LD DM3, and then since this one is start, so we will, maybe we can use this one. Would I? R3004, and then say up. So say up one. So this one is can say up already. And then this one, then complete the rank. So X, so V, since this is a message. Okay, let's start. Simulate. Oh, cannot convert. See. Okay, simulate. Okay, start. Oh, port product, start. Then click on. So it is on already. Oh, means because this one is wrong. So I lack of 10. That is wrong. So I need to update only this one. Simulate. And then this one, cycle complete 1. Should. So I think I have a wrong address. Let's see. So yeah, 1 minute. This one is should 00. Bye. I put it 1 here. So sorry, because I put it as, I should put here this one. Since we are using a DM, this one cannot be a bit already. Okay. Whole word already. Okay. So now cycle complete. We have a message that it is, this process is already cycle complete. Remove the parts. So we will remove the parts, and then we will put the parts and then start. If we never click this limit switch, so limit read switch time over. So once we click the limit switch, and then process will be complete after, and then we have already a cycle complete, remove the parts. So okay, so our cycle is already complete. So you have already an notification or a message that this process is already complete. So you need to remove the parts and then start again. The cycle will be start, and then click, and then start, and then after finish, you have already a message that it is complete, remove the parts. So basically, that's all for this application. So I think that's all. So we already eliminate because our example is only work object, start push button, cylinder down. So once it's not satisfied the cylinder down, you have already a message that limit switch time over, and then you cannot start again if you never remove the parts. So you have also a display that it is a cycle complete. Remove the parts. So I think that's all for this orientation. Sir Dan, I have some questions.
Okay. Now, it's after the session. I would like to ask if you have any questions, you can actually ask now, Sir Argel, regarding on this PLC programming.
So so PLC is only one controlling device if you are an automation engineer. This one is only for the PLC side. So every software, they have their own different programming. So this one is only a PLC. So if you want to see the Omron, it's totally different also, but the same addresses and same command and same logic. But if you want to control the machine, of course, if the machine has a different function like a vision system, so PLC is the one who control the vision system, but you need to program the vision system itself. Same as in if you have a robot arm, the robot arm have its own controller. So you need to program the controller and then integrate it to the PLC like that. So this one is only a basic for a PLC programming and its logic.
I'll be frankly honest with you right now. Kasi sa akin, I'm more on the infrastructure side. And then once I saw that is the same thing, what we have in the infrastructure is kailangan mo rin mag-design. Which is sa design, iba yung application or yung language na ginagamit. Siyempre, in the infra, iba din yung gamit nilang mga syntax, declaration, or what. But it's the same thing, same idea, same concept. However, the difference between the infra and the automation side, because you handle a big chunk of it. Siyempre, automate mo lahat ng sequences eh. Hindi naman basta-bastang gawa ka lang ng gawa. End up, hindi naman nagsi-sequence. Then might as well, your design will not actually be a good design when it comes to doing automation, one part of it. Okay, for the rest, right, if you have questions, pwede nyo nang i-message si pwede nyo i-unmute yung mic and then mag-ask na po kayo ng mga questions po. Parang wala atang nagtatanong, sir ha. Ikaw na lang kaya magtanong. Magtanong kaya tayo sa mga participants since I'm curious because nobody's asking the questions right now.
Hello, good afternoon. Can I ask a question?
Yes, sir.
Actually, it is not a question. Okay. Based on my observation, though I am not into this area of specialization, so what I just noticed is that this PLC is maybe an applications of what we call yung tinatawag nating sa, as I mentioned earlier, sa advanced manufacturing kasi, di ba? So sa advanced manufacturing, yung halimbawa yung conveyor, right? The conveyor needs to have some programming or logics for it to process in various stages, di ba? And then meron din tong mga sensing capability. So which I believe it uses itong diniscuss ni Sir Argel. So that's why yung mga estudyante natin na magiging future practitioner and faculty, siguro they can relate it dun sa mga direct application. Kasi if you will just look into it as a PLC and then without having a direct application, So medyo iisipin mo, no? So how can I use this stuff? Parang ganon. But if you will think of it that this one can be used in a conveyor, di ba? O kaya gagamitin to sa pagmamanufacture ng mga kotse. Kasi it is robotics ang nagmamanufacture ng mga kotse, di ba? So makita mo yung mga malalaking robotic arm, right? Especially, halimbawa, eroplano, di ba? Boeing, di ba? Yung mga ganon. So they uses a lot of programmable logic controllers. PLC kasi yun, di ba? So there is a lot of controls. So there is a lot of mechanism applied so that the outcome will be the same. Kasi it is talking about more on precision. So pinag-usapan na natin ngayon yung next stage is precision. So PLC is, we could say it is more precise. Okay? Kasi pag human ang gumawa, so merong percentage of error at malaki yung gap. Therefore, the outcome may be different na. Right? So yun. So, yung mga engineer diyan na gustong mag-divert into this area, so look into it as a preliminary, and then if you apply this on a certain industry, sa manufacturing, sa ibang area, then you will appreciate it more. Actually, as I mentioned earlier kay Sir Argel, because last time I took a course in advanced automata theory. So automata theory, we're talking about automaton machines. So automaton machines is more on logical computers. But if you apply it into a physical, so ito palabas ito si PLC. So that's why PLC is one of the area na pwede ninyong puntahan. So pwede rin ito sa area of mechatronics. Kasi may mga controllers din doon. 'Di ba? Mechatronics, robotics, automation, ayun na, kasama na doon. Then this PLC will not stand alone, so it will interface to other fields. So pag pinasukan mo na rin to ng artificial intelligence, so mas maganda na yung outcome niyan. Kaya hindi lang siyang one area. So it is a complementary field to advance the engineering profession. Okay? So yun. Kaya maganda itong aralin. And then maganda rin itong ituro sa ating mga engineering students. Okay? So next, sir, how can I download this software so that the student and faculty can practice this PLC?
The Kenyans have another trial version. They can download it on their website, the Kenyans. So you can limit, I think, a trial version of 50 times, I think. So open and close. It's not a 30 days only. It's not a 30 days period. It is a 50 times use. So if your computer is always on and your application is always on, it's considered as a one use. So if you close the software, so that's the time that you will count one.
So pag hindi pinatay, sir, hindi siya bibilangin.
Hindi siya bibilangin.
Okay, so ayun ang tip, mga kasamahan sa industriya. So if you use this trial software, so don't close the application or don't turn off the computer as much as possible para hindi bilang yung days, tama, sir?
Yes,
Okay?
sir.
So maganda rin ito as your exploration dun sa research. What research can we start in the PLC area na pwedeng i-apply sa ibang field? As I mentioned nga, sa advanced manufacturing, sa robotics, mechatronics, di ba, automation. So how we can
If we are,
improve?
Actually, if we are computer engineering is it's already goes to microprocessor. So you can program it and then we change the program.
Okay. So ayan. All right. May tanong dito. Can they have a copy of the video recorded? Yes. We will have it uploaded in our ICPEP-SG YouTube channel. So once it is uploaded, you can view it there. Okay, sir. So meron ka ng subscriber niya. All right. Any other question?
Question, sir. Regarding on dun sa software, ano yun? Sabi mo, pag close, hindi na siya tawag nito, kakount siya as 50. What if...
Kakount siya as 1.
Kakount siya as 1. Pero kapag ni-reinstall mo,
it will, siyempre, consider na magka-count na siya, di ba? As 1. So, same as, sir, the good thing in the Kian's PLC software na trial, hindi siya 30 days version. So yung mga 30 days, after na-install mo, magka-count na siya as a day 1 to 30. And then after 30, hindi mo na siya magagamit. So in the good things in the PLC, the Kians, and also, I think Kian's very supportive. Kung mag-email lang kayo if you are a group or you have school that needs support from Kian's, I think they can give you.
Oh, then meron silang education price for those ano
I
to.
think yes sir because we use this one as internship eh. So lahat ng mga bata na mag-install tinawagan sila why they install it, why they are using it. So ganun.
Oh, ayan, for the institution, they can actually
Kian's very supportive.
ayan, merong ano to, pwedeng yung mga institution to subscribe or they can actually coordinate with them. They usually give ano to, education price also. It's much lesser compared sa corporate.
I think for now you cannot see it as I think it's not a good interesting because you never see the application itself. But if you can see the good side of it or the machine that runs by the PLC, maybe it's very interesting.
Yes. Kasi based dun sa ano to dun sa information about dun sa PLC on how it applies. I remember during my time when I was working in Manila, I was working in manufacturing. I don't want to mention the name of that manufacturing company. It is integrated with, sabi nga ni Sir Ryan, yung conveyor belt. Yun talaga malaking system siya na in-integrate and then it combines with Unix. Medyo malaking system. Kakaiba nga eh. Meron silang mga handheld, meron silang mga nag-i-integrate everything. Kaya isang part lang itong PLC if they are interested in. But kapag napunta ka na dun sa robotics, mechatronics, this one will be a big thing actually. The IT is one part also at the same time.
Right. Any other question from the crowd? Okay. Sige. So if there is none, so I think let's call it a day. Thank you, Sir Argel, for supporting the community. So it is very helpful to share your industry insight sa mga faculty natin at student. Okay. By the way, class tuloy na. By the way, si Sir Argel is a practitioner. Okay, an industry practitioner in the field of automation and PLC. He has an extensive work niyan, not only in Singapore but also in the Middle East. Kaya alam niya yung mga iba't ibang system kanina na pinag-uusapan. Okay? So if you want to learn more of this, so add nyo lang siya sa Facebook. He is very accommodating. Okay? Napakabait niyan. Maniwala kayo. Okay? Then nag-handle din siya ng ating virtual internship. So i-share niya rin yung kanyang expertise diyan sa field ng PLC and automation. So ayun. Okay? So salamat. Before we end this talk, okay? Most likely we will have another a webinar. Okay? So by June na siguro. Okay? So I am planning to have a webinar sa June 5. Ang dalawang topic siya actually. So one is theater management system. So yung mga gustong magtrabaho as a theater engineer, so at least you will have an idea how a theater management system works. So ano yung mga pwedeng opportunity doon. So it will be shared to you by June 5. Dalawa yun. The first talk is yon theater management system. Then the second part, medyo matagal siya, 2 hours talk siya, but it is very interesting. The topic is more on satellite communication system. Okay? So we will move na dun sa mga satellite kasi Philippines is now in the race of satellite industry, di ba? So at least we could have an idea ano ba yung na yon, value ng satellite communication sa atin. So it is a good opportunity for you to learn, okay, the concept, the basics of these two new topics, okay, especially sa computer engineering. Kasi all of them is contains what we call computer system. So sa tingin niyo kapag nag-boom ang satellite systems or satellite industry sa Pilipinas, so what is the opportunity for computer engineers? Okay? So saan ba tayo papasok doon? So having the concept, the knowledge of the satellite communication system. So makikita ninyo, pwede pala tayo to work, to collaborate in this area, right? So we are not only in programming, we're not only in hardware. We're not only in infrastructure. Computer is everywhere. Okay? So even your mobile phone is considered a computer. Okay, you have input, output, processing, and everything. Okay? So that's why ICPEP Singapore is aiming to expose all of you in the latest trends, innovations, and technologies that we can be part of this development. Okay? So I hope all of you can also attend on these two events. Okay. So don't worry, the event is free for all members. Okay. And partners in the community. All right.
Right.
Again, thank you, Sir Argel, Sir John Pagirigan,
Don't
for the time. Okay. Can we have a group photo? If you could open your camera, mas maganda. All right.
open po yung mga camera po natin, mga videos.
Yan. Let's open the camera. Sir John, can you off the recording?
Wait, sir.
Yan.